Hello and welcome everybody. My name is Tabiso Miataza. Today we'll be looking at IGCSE physics and we want to look at moments and levers. We will be discussing those in conjunction with each other. Right, what are moments? Wait a moment now. What is a moment? Okay. Sorry, I couldn't resist. Right, I know it's a cheesy joke. Let's go on. Right, moments are defined as the force multiplied by the perpendicular distance away from a pivot. So the force applied by a particular mass multiplied by the perpendicular distance away from a pivot. It's very important to note that the distance has to be perpendicular. That's the first thing. Okay, why is that? Remember that force and displacement are vector quantities. Okay, so we have to specify that direction. Suppose that we have a seesaw and two people are sitting on a seesaw. Just to make this interesting, let's say one person is Dula. Okay, in other words, they are round challenged and the other person is not so stula. Okay, so we have two people sitting on a seesaw and those two people obviously are applying a certain force on the seesaw depending on what their masses are. The mass of this person is 50 kilograms. The mass of that person is 30 kilograms. Now, we can calculate the moments, whether okay, the resulting moment from this particular setup, and we can also know whether it is a clockwise moment or an anti-clockwise moment. We can also calculate whether the moment, whether the system is in equilibrium or is balanced. There's no motion at all. Okay. In physics, if you think of a very practical example, a crane, one of those huge cranes that build skyscrapers and everything. On the one side, it's got an arm, a really long or sometimes even extendable arm with a mass that's movable from the pivot, from where it's being controlled. And on the other side, it's got a shorter arm, but it's weighted. Weights are put on it to balance out the effect on the other side of the crane. Okay, so if you think about that, in physics, we want to know how to balance it. How much weight should we put on this side so that it remains stable on the one side of the crane? Also remember that the mass on the one side, on the extendable side, is movable as well. We can move it back and forth to reach wherever we want it to reach. So we have to make sure that we have dynamic equilibrium, or we have a stable crane which will not tilt over as the masses move over, or are moved over on the one side. So what we are going to do here is let's have a real tangible example from this setup that I have on the board here. So let's suppose we want to calculate the moment that is being experienced there, whether it's an clockwise, anti-clockwise, or whether the whole system is balanced. So this is what I'm going to do. I am going to give the distance from the pivot arbitrary values. Okay, I'm just totally making this up just for the sake of explaining what a moment is. So we call this the pivot or sometimes the fulcrum. We call these the loads because these two people are loading on the seesaw. Think of it as crudely as that, or they are putting weight on the seesaw. If we imagine the distance to be 2 meters from the Stula person to the pivot, and we imagine the same distance from the not so Stula person to the pivot to be 2 meters as well. What is the resultant moment from the system? Okay. First things first, we need to calculate how much force is being applied by that person, and we need to know how much force is being applied by that person there. We know that the force is the same as the weight. Weight is mass multiplied by gravitational acceleration. And for this For this purpose, we shall take it as 10 meters per second squared. I know physics fundies will say to me, no, it's not. It's 9.8 or 9.67 to be precise. Let's take it as 10 for simplifying our calculations. Okay, we shall not go into all of that argument. So F, that force is equals to weight for that person, again is equals to mass multiplied by gravitational acceleration. So the force that we are looking for, or the weight that we are looking for on this side of the seesaw will be 30 multiplied by 10, which comes up to be a very nice 300 newtons. The weight that you are looking for on this side is going to be, again, a very nice 500 newtons. Please be careful. When you are calculating moments, do not use the mass multiplied by the distance, as I often see when I am going through people's work. It's always force multiplied by the perpendicular distance. Also, please be careful. There are so many tricks that come with this question. One of the tricks that come with this question is you might be given all sorts of differences, all sorts of distances, but if that distance is not perpendicular to the force applied, as you can see here, we cannot use that distance. You only look for the perpendicular distance, F multiplied by pep D. Okay, and that is what a moment is. Moments are defined as the force multiplied by perpendicular distance. Right then. Now, we have two scenarios here. So, this system here, if we look at this system, we can see that on the right-hand side, we have a much bigger force than we do on the left-hand side. So, if you imagine this as a rotating system, obviously because it's got a pivot, then we can conclude that to balance this, you will need a resulting 200 newtons. So the resulting moment, mom res, is 500 newtons. Take away 300 newtons, which becomes 200. That's the resulting moment. We have to specify in which direction that moment is acting. So the resultant moment is 200 newtons. Now, because this is a rotating system, we specify this in terms of either clockwise or anti-clockwise. Okay, so at this point, we can see that it is obviously the stool person is going to lift the not so stool person up. So that imbalance there happens because the whole system shifts downwards, and this is the same as clockwise. So this is a 200 newtons clockwise moment. Just a mistake I made there. I do apologize. The units for moments are newtons per meter, Newton meter, and Newton meter. So these moments also, it's nm. So it's going to be 200 Newton meter clockwise. Good to know that I'm human. Yay! Okay, I also do make mistakes, and I hope you are learning from those and you don't make the same mistakes in your assessments or in your assignments or whatever. Okay, or in your fun. Maybe some people just do physics for fun, not to be assessed on. Okay, I would do totally. Okay, if I'm bored, right? So I digress. Do apologize. So the resultant moments is 200 Newton meter clockwise direction, in a clockwise direction. Okay, thank you very much, folks. I hope that helped. Please let me know if you need me to explain anything further from that. Thank you and have an awesome day.